this is going to be a panel. So we had the general intro stuff, the power of the syllabi, we had the legal and social challenge, and now we're going to talk about the technical challenges involved in the project. Now I'm really excited because you'll see here a panel of people who come from different backgrounds and who are working with projects that have some of the same technical challenges and some projects that probably have a lot of lessons and a lot of lessons to teach us, and we can learn from them a lot. So I'm very excited about this panel. My job here is to kind of give you slightly a more technical architecture, infrastructure snapshot of where we are now, give you some of our philosophy behind making these technological decisions, and also really ask for your advice, because I can't tell you that, I can't stress this enough. 1 year ago, it was literally like 2 people in an office, kind of doing things, you know, as best as we could, and it is really great to see everyone here. And my kind of goal as kind of the technical lead on this project is to make sure that the decisions that we're making today will scale to kind of a larger archive and to a larger audience, right? So if you have any input, feel free to interrupt me or come up to me later, or better yet, come tomorrow to the hackathon and help us improve this infrastructure, right? So let me give you kind of, let's start where I left off in my previous little talk, is that this is, what you see here is the usual kind of data analysis pipeline, right? You usually start with some collection stuff. Then you do things roughly in this order. You ingest things somewhere, like somewhere where you can process them. You start extracting things that interest you. Maybe university, in our case, we collect syllabi, we ingest it as plain text into a database. We start extracting university names, citations, right? Kind of the usual extracting stuff. And then you start analyzing. You start writing papers, right, on the long history of the disciplines or canon formation or whatever, right? So that happens here. And finally, you start seeing kind of applications, usage case scenario. And as I said before, we really were hoping that our efforts here bring people to the table and start a conversation about intellectual property in the university, and that we can use it kind of as a policy, as a tool for policy. And of course, as was pointed out, this shouldn't be a straight line. This should be a circle, because once you get to the wider audience, you want to start thinking about a process of collecting this database. You want to, in the perfect world, we would have institutions kind of automatically deposit, right, their collection into something like that, into an ecosystem, into an architecture that does something smart with these documents. They're not just kind of languishing like those puddles I was talking about. They're not just languishing in a server somewhere in the basement. So that's the general data pipeline, right? We got that. Now let me tell you how we decided to address that pipeline in terms of specific architecture. First of all of our stuff lives on Amazon AWS. It's all in the cloud. We collect things. We are on Debian Unix, so basically there's an archive, which is just a filing system, Unix filing system, and we're getting stuff via multiple kind of vectors. So we are scraping. That was our big kind of let's get to critical mass. We do have some user submissions. We just opened up a way, as you saw, a way to submit via Twitter, like quick and dirty way, right? Fun way to just tweet to hashtag, not at, hashtag OSP submit plus link. Very easy way to get your file into that system here. And there's going to be a web form probably to submit larger chunks, zip files, and so on. So we're looking for multiple kind of vectors of collection on this side. All right. So that's the first part. That's the first part. That's the collection part. The second part, right, is ingestion, extraction, and so on. So what happens on this level is that we have kind of a bunch of really lightweight scripts. We're going with Python, but because they're modular, we don't really care what they're written in. But what the scripts do, they're kind of like janitorial maintenance scripts, and they go over the filing system. And the first thing they do is they pull in the plain text, right? They pull it into MongoDB right now. They pull in the plain text. They know what they've already processed. So it's an ongoing thing. And these scripts begin to extract things. So you can imagine one script that starts working with that plain text, extracting university names, extracting citations, doing topic modeling, and so on. The idea here is to make it very modular. That way, if tomorrow a research team comes and says, we are interested in, for example, that field of disability disclaimer, right? We want to know how accessible the syllabus is. It's something that we did not think about in our data structure, right? They can kind of get in here, write a little script that just takes out the disability part, right? Disability disclaimer, and adds that disability disclaimer as another metadata field that belongs to this document, right? So you can think of a document, each document gets pulled in, the full text gets pulled in, and then hopefully, our hope is that with time, that metadata for each document will become richer, right, and more three-dimensional. And I would say we are somewhere, we are in that moment along the pipeline, right? We've done a lot of the collection. Like I said, it's not a finished process. Collection will go on. This is a circle. We've done the ingestion, right? We have the over 1 million plain text extracted fields in here in MongoDB, and we're beginning the fun stuff. I mean, this is why we've invited you all here today, is because now we can play. Now we can do topic modeling. Now we can do machine learning. Now we can do extraction, right? This is where a lot of the background piping has been laid out for you, and we hope you make full use of that. Right, so that's how it works here. Now there is a little bit, we have to do other stuff like back things up, make sure that we have redundant storage, right? All this stuff to ensure that our hard work does not disappear if somebody messes up accidentally, right? So we are thinking about robustness and long-term sustainability of this architecture, and at the same time, I think it's fairly modular, right? Fairly lightweight. We're using usually open source, very, very kind of vanilla products that are easy to scale. There's a good user base of people who know these technologies, right? We're not using like a lot of custom-made stuff that's not accessible to the world, right? Does that make sense? I know I'm going fast. I know not everybody's technical, but just general picture. There is a server somewhere that's constantly churning, that's constantly enriching the database. Now, it's on a server, right? You have to, if you're interested, and I think there are a few people who need access to the server, we're very happy to provide a developer kind of level access to the backend, but most people don't need developer access. Most people would like to access that whole structure from the web, right? For this purpose, we open up an API through the kind of the HTTP barrier. The API exposes just this part, the MongoDB part, to the world, to the web, right? The hope there is to have people, independent research teams, and there's several one of those here, independent research teams that can go out and do whatever they want. Some kind of cool visualizations of the timeline or historical. It gives you independence from kind of our backend, right? You can really get up and running on your own using the API and knowing that that API is constantly being improved on the backend, right? So that's how we approach this. The API is Sleepy Mongoose. It's the regular. Oh, that's a scheduled fire alarm.
No, it's my alarm.
Oh, it's your. Oh, there was a sign.
Tell me that it's one of, in 10 minutes there will be a scheduled fire.
Nice. Very nice.
Sorry.
That's okay.
That was the fire drill is a fire drill.
Yeah.
We meant to set that on silent.
Right, so where are we? Right, so we hope, and I think we're going to see some of these applications pop up this summer. Once the API is released, it enables the development of, let's call it like web apps, web services, right, that are somewhat independent from us. And so we are tomorrow we'll be going through the API and handing out keys and really talking about how the API works, right? Does that make sense so far as these things tend to make sense? So that's more or less our kind of bets, our technology bets and our infrastructure bets, and that provides you a way, I think a clear way for you to interact with us, right, through these kind of two major ways. Either developer access here, quite, I would say limited, and it should be limited for people who know what they're doing, and front end HTTP kind of API on the side. Yes?
For app developers, have we figured out like how to attribute OSB? Like,
Yes, how to cite it. Yes, so we do have, I do believe there was we have kind of how to cite as page. And there I have to say, we borrowed from the team, the Citeseer team, who are doing actually very similar things with similar infrastructure and architecture, but with articles rather than syllabi. A lot of the same kind of problems that we're solving technologically and in terms of intellectual property. So they have a great page saying, like, here's how you cite our database. If you're using our data for your app, here's how to link back to us. And you see, this is a group of people who are, we are right now, like the people who are very invested in this space, and I hope that we do a lot of kind of this cross-pollination, and we'll link back to you, you link back to us. Right now it's easy. If we grow more, we have to start worrying a bit more about, somebody coming in and trying to pull through the whole archive or something like that. But right now, I hope it's not the problem. Any other questions on this side? Yeah.
Well, I was just wondering if I don't know if it's appropriate or not, but if you had thought about making like an Amazon machine instance where if somebody wanted to, spin up their own instance of it.
So yes, that's very easy, and this is why we went with Amazon, because it enables us, it's very easy for us to take this whole snapshot as is and just make a copy, kind of a workable with exactly the same environment. Here's the problem, as we were talking about intellectual property, right? We don't quite have rights to share these documents, really, right? And this is why our approach was to expose to the world some metadata, a limited subset of the metadata we have, and that gives us control. For example, we can sanitize the names of individual instructors. It gives us some control. Now, let's see how it plays out. That's the hope. For this reason, people who need access to the backend, who need kind of deep dives into this archive, they will probably have to sign something more serious that says, I promise not to share these documents beyond research purposes, and we're working with legal to make that happen. So one is the barrier of entry, both on the technological front and on the legal front to here is greater, just because we don't want to get in trouble. We want to get a little bit in trouble just so we get more people to the table talking about it, but we want to remain vital, remain in operation. So that's the deal. We can make it very easy, but then you'll immediately see kind of usages that kind of we probably don't condone or something like that. Yeah.
And I might not be making the right distinction, but
yeah.
I hope I am. Is if the data is the water, and then there's the bucket. Is there any thought of making the bucket open to people?
So just Mongo.
Well, I mean, there's one, I don't want to call anybody out here, but, sometimes there's this notion that something is an open source project,
yeah.
But when it comes down to actually having an instance of that, putting everything together,
yeah.
People don't have the technical wherewithal, so like one of the things that we're doing is we're just dropping an AMI of our software onto somebody's account. So all that stuff is taken care of configuration-wise. Yeah. Would that be a possibility?
I mean, I think so. So right now, there are various ways in which we try to answer and make good on the promise of being open. One is having a clearly documented API with kind of relatively ease of access. Two, our code and our documentation on GitHub are all licensed under Creative Commons and other kind of software, free software licenses. So yes, but this part of it, we are not even at liberty to license at all. So yes.
Perhaps an AMI of what's on the right of the squiggly line.
Yes, that might be. That's a possibility.
So if you said like we vetted this certain subsection of database that can be released because it's been cleansed or whatever, but I want to run it in my own instance for whatever reason.
Yes, so that's a possibility. Betting, kind of making a smart bet on Amazon allows us, it is a very easy way to share huge kind of blocks. You can share an elastic block with like a terabyte of data without a problem. And I have to say, in these decisions, we rely on the advice and expertise of the teams who have faced the very same problems at Citeseer and elsewhere, right? So here I'm really We don't want to reinvent the wheel. We want to follow the best practices in this field, right? It's a particular field that we're in, and so that's why we're here, right? Part of our tomorrow hackathon mission will be, the non-technical part will be exactly to kind of think out, review our legal documents, review our licenses, kind of see whether this community, the very interested community, is kind of on board with the architecture, both technical and legal. So yes, I mean, it's a possibility, let's put it this way. The architecture allows us to do this easily if that's what we decide to do. All right, so very quickly, I'm going to, this is actually, we need a lot of help on this. Right now, the way the server is set up, that's basically on this side. The way the server is set up, we have two servers. We have a dev server, like I said, where you can get keys. You can get access to the dev server. We have a production server. This gives us a sandbox environment for people to come in and break our stuff, basically. So come in and do break it. The way it works right now is that code is bubbling up like this, and probably with GitHub. So there's really, it's exactly like that. There's 3 folders on the server. You'll see more of this tomorrow. There are 3 folders. One is code, and the code is synced with GitHub, and it bubbles up from development to production. The other folder is archive, which actually contains kind of the fruits of our labor so far, and that's where the documents live. And right now, that folder bubbles down. So right now, we are collecting actually on production, which is a little bit scary, and we bubble it down. Occasionally, we make a snapshot down to the development server to give the developers kind of more of a recent snapshot. This, I can tell you already that I think this needs to be fixed, because we are right now not, because collection is happening here. If there is any kind of reduction in quality, if there is any corruption of the whole archive, we're not testing for that. And I think as our development team grows, we have to institute some sort of testing server in the middle or something that prevents that. We need help with that. And finally, we have the database, which is also being bubbled down right now. And I've been talking to people here who have system administration experience to make sure that I think the next step would be to introduce some sort of testing, another server that's testing server that lives between development and production, that does some kind of self-testing, right? Some sanity testing. We're extracting stuff from the archive into MongoDB. What happens if during the extraction process you accidentally delete a bunch of fields, right? Right now we're not. Right now it's because there's like only 2 people involved. We're just eyeballing it, but it would be very good for us to again create a much more robust way for dealing with this. Now it's a little bit new to me because for many of us who work with data, working with such a large archive, right, is an interesting problem, and I think there's a lot of kind of experience and a lot of problems that can be applicable in many research problems in the humanities that have this kind of shape, where you're collecting, extracting, right, and using at the end. That's, in short, this is our architecture. In very short, these are the problems that we're facing today. We'll be talking more about this tomorrow during the hackathon, and I really, really welcome your input and your advice. All right, so any questions for now?
I have a question.
Yes, absolutely.
How many users do we have for API?
None, because we have not. So the API was finished this week, and it will. So it's working. We've been testing it ourselves today, and we've pre-made about a dozen or so keys, just so we can very quickly get people up and started tomorrow during the hackathon. But that was one of our major kind of release dates, is to get the API released.
I'm thinking of that because eventually you will want to put it in the search engine, because the database is not good for search. It's good for storing data.
Right.
Right. And also, especially, well, MongoDB is NoSQL, so it's pretty fast and scalable, but it's still a database. So, like if you want to do searching, like it's just solar machine.
Right, right. And we've been talking to Lee, and we've been talking to your team about that. The thing is, our kind of first scenario was not for user coming into the website, searching through the documents, which we don't even know if we're allowed to do. Our first kind of use case was research. And with research, MongoDB was the quick and dirty way to get it up and running. And I think we're really strongly looking into that stack of like Solr and kind of the search engine stack. Maybe we need that, maybe we don't. You know, I'm not sure at this point. And talking to Lee Giles, who's the PI, right, on Citeseer, he was very interested in seeing how far we can get with Mongo towards some of the use cases that you guys are doing as well. So I think that will be an interesting. The plan is to take MongoDB. Right now, we haven't hit the point where the fact that we're a database-driven architecture, it's not limiting us right now. Though I think you're right, there will be a point where it is limiting, and at that point we will look into a kind of adding another stack like Solr or something.
There are a lot of features you can add, like for example ranking. So you may want like the users to rank their certain results, and you don't want them to dump all of the results and do the whole process themselves.
Right.
So you want them to see, okay, like I want the syllabus machine learning, and I want like the most relevant ones in the most recent years, like they can rank it.
Right, right.
Yeah, that they want. So that could be a very good feature.
Yeah, no, absolutely. And for people who are kind of non-technical people, there is what we're talking about here is there is a way to kind of make a search engine, to make something like Google that goes through our archive and pulls out results based on relevance and page rank, and we are not quite. We are more a database-driven thing where you can run queries. So you can say, give me all the syllabi that are in a category of chemistry, and it will kind of return query results, but it's not the same as search, right? So search is much more free form. It does this like fuzzy matching, page ranking, this kind of stuff. We're not doing that yet, and that's a use case that was kind of farther down our list, farther down the list.
It seems like if you reach the point of doing full text search, then you will need Solr, but now if you are only dealing with metadata, then probably database is fine.
Yes, yeah, that was our thought. Anything else? I mean, like I said, take a moment to digest this, and this is something we're really going to get to the entrails of this tomorrow if you're interested. But also remember what Joe said, is that it's not just tomorrow's hackathon, and what Ted said. Tomorrow's hackathon is not just technical. There'll be several teams who are probably interested in getting in here, but if you're more interested about the IP issues involved and about documentation, please come as well, and there'll be plenty of kind of, we're facing other problems as well that you could participate in. Please.
Are there any particular applications that is in your roadmap that you want to see people bring some, or is it like just dig into the data?
Yeah. So our original kind of dream was just, and this is like my, as a junior faculty member, I do this all the time. You're creating a new course, and you want to see what frequently, so you're teaching, Shakespeare 101, you want to see what happens, what are the commonly assigned texts in Shakespeare. So that kind of, I think that's a very basic and fun use case that we'd like to address quickly. But the good thing about this is that there'll be some apps that we don't anticipate. So I know there's several people here who had ideas that kind of are not right, that they can take this API and run with it in some other direction that we don't anticipate. And that's the idea, is to enable an ecosystem of apps. Yeah.
It's just like a cool thing that I'd like to see is like having a mechanical Turk for the documents, and have the task be meta tagging and like that. I was talking to someone, Alex, earlier about this, and just like have like a set of simple tasks that we can start actually meta tagging a lot of these. Like some of them are text, some of them are these crazy drawing images. That would be really useful.
That would be great. And if you, I don't know if you were here. There are several projects that have done hand coding of like a small corpus that will be very, very interesting at some point to kind of this mix between human intelligence and machine intelligence will be quite. And then the nice thing is that there is already, these guys are pretty far along the coding process, and that's a really great way for us to work together. But yeah, mechanical Turk also, if we...
Yeah, I found in one of my research projects that you can then incorporate supervised techniques as well to blend the process, because there's a lot of error in mechanical Turk. But you actually dramatically can improve the results of the mass, as long as you have money, of course, too. That's the other thing.
Yeah. I mean, it's money, and I have to say the enthusiasm from researchers, right? So I know Rachel's been, right? You've been tagging stuff.
Yeah, we're just doing a small corpus this summer.
Yeah. So, but small, like 600 tagged syllabi. That's significant enough to do some kind of blend between supervised and supervised. So that's really exciting. Hmm?
Manual.
Yeah.
We're setting up the metadata schema now and having students do it. So.
Oh yeah, that's what they're for.
Yes, please.
What sort of order are you going through the syllabi to process them? Do you have a prioritized order, so you're trying to do the newest ones first, or you're trying to do English, things in the English programs first? Or,
No, we just go through the file system as kind of in an ad hoc way. So there is no order, and then there is the little maintenance scripts that are pulling in the full text into database. They just know what they've already done, and so if you basically, when a new syllabus arrives by Twitter, the little script knows that has not been processed and pulls it in. So there is no, right now, because our collection, I called it greedy collection. There was no, we did not go, we are going to start with English, and then we just kind of grabbed.
I guess I wasn't clear enough. I mean more on, not for the ingestion, but for for making things so that we can actually query them through the API.
No order right now. I mean, we're just running mass. So we literally last week finished the ingestion of full text, and we're hoping our kind of next big milestone is by the end of the summer to have a much richer metadata structure by doing extraction, right? So we're doing all kinds of extraction, and I think we do have a very good order. The order is we grab the low-hanging fruit first, right? So there are some very difficult problems that we may kind of reach out to the CS department. I don't know, parsing tables or anything that's not text is absolutely a difficult problem that we might not get to by the end of the summer. Topic modeling, guessing with some measure of certainty the field of the syllabus, guessing where the university is, getting some kind of, the usual natural language stuff. That stuff is easier, we have more experience, and we're going to start there, right? You start with the sun shines, right, when you lose something. Yeah.
Maybe just a little bit of conceptual clarification, especially in light of the mechanical search suggestion and what Rachel was saying. The arrow of the API kind of goes in one direction. Are there mechanisms where interpretation or analysis can go back upstream? And so when you're on the outside, can you contribute some information back? Like, this was not a good match, this was a good match, or anything like that?
So, great question. Yeah, so the question is, what can we have? So maybe somebody's tagging things, or as they're searching for things, contributing. So that's in our kind of feature list. And the nice thing is that the API that we are using does allow for writing. So we conceivably yes, but it's not the it's not the easiest, and it's not the first thing. So yes.
So what Rachel's doing is requires access to the dev side.
Right now, yes. But again, to come back to this is like the highest level of conceptual level. It is very much a circle. So once we hope that once we expand beyond this group, right, that we really have people who can contribute back, maybe 1,000 hands doing one little thing. That would be great.
Then you're going to need to decide exactly what you want to tag, right, and how you want to tag it, or I guess you can be parsing necessarily, But, so that's going to be important, right?
Yeah.
Exactly, so that it's searchable by, okay.
And it's not easy. That's why that's it's later down the kind of development line. Yeah.
Hey, so I'm actually in the CS department here, and like Niels and I are looking to do some topic modeling on the entire corpus, and we're also looking to associate each individual syllabus with Wikipedia articles, which is going to be pretty cool.
Yeah, that sounds cool already.
But we're wondering how much of the actual corpus are we going to have access to, like starting tomorrow?
I love it. So tomorrow, like I said, for the devs, we can get you access to the full corpus as long as you are willing to kind of. But especially, because right now our only worry is just an illegal, and I think especially if you're Columbia, it's relatively straightforward. Architecturally, it's trivial to get you access to it, but we suspect it will be a common thing where researchers come in and they say, actually, we have a very advanced kind of research project that requires us kind of deep dive into the archive, and I think we are working hard now with the advice of Kenny and the advice of Kenny Cruz and others to have like some document where you say like by getting to the server, I promise not to use personally identifiable, like something like that. I'm not sure what that would look like. Kenny's like, not me, I'm the
I just changed my name.
Yeah. But yeah, we're working on that, and if you're eager to start tomorrow, let's do it. I think we can do it.
I think we are.
Yeah. All right, perhaps let's move on. Like I said, we'll continue this conversation. Did you guys have an idea of order? Do you want to go next one?
Sure, yeah. So I'm a fifth-year grad student in the computer science department, and mostly I'm doing natural language processing and machine learning. And my thesis is about extracting social networks from unstructured text. So we're extracting networks from Enron emails. So there's, people usually use the Enron metadata, send, reply to, or these kind of links to sort of infer things like organizational hierarchy about the organization. But we know that the sample that we have of the email data set is very biased. We only have very limited number of emails from the actual organization. So we don't have interaction links of all the people. So what we're doing is looking at the text of emails, because in the text people mention, I had dinner with X, we had a call, why don't we chat on the phone? And we're trying to enrich this sort of interaction network and see if we can better predict either the organizational hierarchy, or we can find some hidden links that are not expressed through metadata, right? And these sort of applications are sort of very interesting for people who are looking for insider trading or compliance kind of issues. So we're actually commercializing this technology, and we recently got some NSF funding to sort of incorporate a startup and then reach out to clients and look for what the market is. So so we're looking at compliance kind of issues. We are also talking to journalists because they have huge amount of unstructured text, and they would like to put some sort of a structure on the text to do some sort of analytics, right? And the main problem from sort of a machine learning perspective that I'm seeing in general is that given unstructured text, there are 10 analysts. Everyone has a different model of the world in their heads. They don't want, this is what usually happens, that you have unstructured text, you debate about what kind of structure you want to put on it, come up with a schema and push the text through to the schema, and then it's a long process, but later on you realize, maybe we need sort of more flexibility, and maybe this kind of structure doesn't fit well for the kind of analysis we're doing. So right now, currently, there doesn't exist technology that sort of supports putting a flexible structure on the data. So I'm an analyst, I'm looking for a question. The way I use Google these days is, I query some terms, make some notes, maybe draw a chart, draw links from one thing to the other, and then finally I get to the answer that I'm looking for. So what we are trying to do through this project is automate this whole thing. And this buzzword that's come around a few years back is interactive machine learning. Can humans work with the machines? So this process of training the machine of what the human is looking for, becomes easier, and we move. Everyone knows annotation is painful, but if we can sort of move away from, hiring grad students to annotate things, and instead, having the person who cares about, the question they're trying to answer, play with the machine, and together they sort of, put a soft structure on all of this unstructured text to do some analytics. So these are sort of problems, and machine learning in general. The way it works is that if you're trying to build a model, you'll try to get some annotated data, give it to the machine. It will learn patterns, try to identify it. But this sort of pipeline, inhibits the user. So people, I don't know how many of you've heard of feature extraction, but people define features. These are the features that we believe will work well to identify these patterns. But if we want to put a flexible structure which is sort of dynamic and can automatically learn on the go, we need to sort of move away from this feature extraction paradigm to a paradigm where data can be represented more naturally, and the burden of extracting those features actually falls on the machine. And there exists, paradigm that allow or support this kind of sort of vision, and so we're exploring one such paradigm in our work. So mainly, the problem we're trying to address is, given this unstructured text, how quickly can we put it into a structure? Because once we put things into a structure, there are companies, Palantir does it really well. Once you have a structure, people have tools, and they have analysts, and they have statisticians who can do the analysis. The big problem now is, given this unstructured text, how can I put some structure on it very quickly, and not sort of a very hard structure, something soft structure, because people model the world very differently from one another. Yeah.
I'm also looking at architectures that do similar things, but more burden on the machine. But in terms of what you're talking about, as you mentioned, interactive machine learning, which is different than active learning, which is kind of just a crowdsourced bootstrapping approach. But when you're doing a dynamic pipeline and you're having a machine learning algorithm that or any AI technique that's continuously adapting to differences in time base, are you saying that you're trying to learn? You're talking kind of about representation learning without saying this term for people that aren't familiar with it. It's just kind of what he's saying, putting learning structure in unstructured data. And so you're saying, are you looking at that family? Because I'm looking at those deep architectures, that family of algorithms. But are you looking at interactive algorithms that allow you to? Because that's a little different, where you're dynamically learning a representation given. Because you're talking about features being selected. Is that? I just wanted to, because I wasn't quite clear, because you mentioned interactive learning, but then you mentioned, you kind of hinted at representation learning. Are you looking at a hybrid kind of model?
Yes, so exactly. So these will sort of go hand in hand, right? So the interaction will allow the user to tell the machine, these are the kind of things that I'm looking for. But now the question is, how does the machine go about learning that concept, right? Now for that sort of a thing, we need a paradigm where we have to move away from feature extraction, because it takes someone in the order of months to define those features, implement them, and actually learn a model, right? So that's the part of representation learning, or generic data representation, where all the data is represented in this one generic format, but the algorithm is such that it finds the kinds of features that are relevant for the task that the user is interested in. So I think it's a play of it's both would go hand in hand. Yeah.
A syllabus is, I'm so sorry, it's going to sound stupid, but a syllabus is already generally structured, right? So you're dealing with emails that are, of course, you're having like the sort of written but oral conversation there that has the dots and smiley faces and things like that. Whereas the syllabus, that we would be dealing with, those are basically already structured, right? Or no?
Yeah, they're not. Yeah.
So there's a term called semi-structured, and Syllabus is part of that.
Well, okay, then maybe I need a definition of structured.
A structured document, let's say, I work for Macmillan, so we publish a few papers every
Right.
year. And a structured document would be title, authors, author affiliation, abstract,
It's like a table.
introduction.
Uh-huh.
So
Yeah.
all of those text fields are associated with a specific metadata facet.
Gotcha.
So then you can therefore do a search against specific metadata facets. So if you're looking for Columbia, you're searching for an institute name. You don't want to pull back papers that use a method called the Columbia method, if that makes sense.
It does. But if for example, at Houston Community College, they all have to use Curriculum. Curriculum has a structure already to it. So we can't say that they all don't have structure. Some will have structure.
So because they're so diverse, so some colleges, some universities have a very strict, like, you know, this field has to be this field. Some colleges use tools that actually provide an absolutely structured, like, XML document where everything is tagged. But in our corpus, because we're grabbing everything,
Right.
we're just more or less treating it as an like semi-structured or really almost like natural language unstructured document. But I think your question is actually super important, because from the very beginning of this project, and when I met Joe, there's been always a talk about schema or not schema, right? And there's several, and this is like almost like metaphysical, like deep metaphysical question. Like, do you want to create a taxonomy like Linnaeus or something, or like Aristotle? You're gonna create Vivo, yeah. You create a taxonomy in the world, and you're going to say, we are all going to agree in this taxonomy. We're all going to agree that the syllabus has to have a disclaimer on disability. It has to have a title. Or do you say that we are encountering like complete wilderness? There are all these animals in the zoo. We have no clue. Some of them have 4 legs. Some of them have 17 legs. And we're just going to try after the fact, maybe in this dynamic way, infer some prominent features, right? That's what we're talking about. Whether a machine can.
Would it be trained to show probability? Is that what you're saying then? That the probability that this would be representative, or
right? Yeah. So in general, everything. I mean, even in the real world, everything is probabilistic.
Okay.
So the machine will, probably say that, okay, I'm so and so percentage confident that this is the structure of the document, right? So yeah.
And it's very likely, this general, and then I know George has his hand up, because George is creating a structured a syllabus authoring tool, and if people use tools like that, it would make our jobs much easier. But it's difficult to convince people to use those tools. So my general kind of approach is all of the above. It's likely that we're going to get some of that dream that we have of like learning from syllabi and using them to enrich the ways we teach, and using them to learn about our own teaching practices. Some of that stuff will come from people adopting structured ways of authoring, and some of it will come from kind of more machine learning, like we're just dealing with messy data and we're pulling stuff in an ad hoc way. And I hope that by attacking this problem from multiple perspectives, and I think in the way we're developing this is that conceivably you can see somebody using our kind of document-centric database to pull it through into like a much more structured authoring tool or something like that. I don't know. The idea here is to develop in such a way that will allow others to do those sorts of things. George?
Well, that's kind of where I was going with like like you said, it's not just the code itself, but like having the machine instance where you can just drop it on an Amazon account, because at least what I'm seeing is, for those people that do have their own structure, certainly I think we should be encouraging them to expose the structure to you, especially if they're passing their data. And so, to me, like schema or not schema, it's not binary. It's not a binary question. It might be for the whole database or for the whole first archive right now. But I think, like with the Smothmore folks, once they come up with this thing that kind of is outlining for them, if we encourage people to start submitting these structures for the practical reason of understanding their data better without having to guess, but then also for the larger reason of saying, eventually we should be able to kind of, like, we're never going to be able to, I don't think we'll ever agree on the display of that information, the formatting, but I think we could agree on a taxonomy, underlying taxonomy, and then, really from our perspective, from the technical perspective, the display doesn't matter. As long as I know what that field is, I don't care where it is in the document. I know what it is.
So, that may be the perfect segue to the Citeseer team, because this team has been working with articles rather than syllabi, and they're much further along, and perhaps you guys can talk about the problems and the solutions that you faced in your research and in your work.
Okay, so the way Citeseer does is that because all the documents, they are crawled from the website, like mostly from the author's website, their homepage, or the faculty's homepage. So we, so in addition to provide a cached version of the document, we provide the links where the document was downloaded. It's pretty much like Google, and all our documents in our repositories are free. So, but you need to contact our PI, it's Dr. Giles, to have access for that. And plus, you must have some way to kind of ship this, because our repository is currently 6 terabytes. So you can't fit it in a hard drive. So, and also, our database, we provide the OEI access. So you can get most of the metadata from the OEI. It's kind of an API, so you can access most of our metadata from the OEI. Actually, we get about, let's say, at least 1,000 requests through the OEI interface every month. So, yeah, so that's our kind of policy. So basically, our data is free, and also we provide a framework called Seer Suite. And that's the framework of digital library search engine. It has been used by some other institutes to build their own digital library search engines, as opposed to be very useful. Yeah, and it's still actively developed. So we're keep adding features in that. Like in recent years, we are trying to add more features, like the table search. Like you can extract the tables from the articles.
So I work on HathiTrust Research Center together with Robert McDonald. So do people all know what is HathiTrust? Okay, that's great. So HathiTrust is a huge digital library with millions of books. So the total number today is about 11 million of books, and so it's a large number of books. And the HathiTrust Research Center, shortened for HTRC, is responsible for providing computational access to the HathiTrust digital library. So there is a little bit of difference here. The HTRC, what we are doing is aiming to provide computational access to scholars, so that people can use the huge digital library to do their work, either in digital humanities or in their informatics work. So they are kind of work at a different scale. There is smaller work like digital humanities. We have their own collections, such as collections of Shakespeare, and they analyze the writing style of Shakespeare, such things. And there is also a large-scale analysis, which you can mine the whole collection as a whole. So that kind of relates to the large-scale analysis. We also have the legal issue because 34% of the books are public domain, and the remaining 66 is in copyrighted domain. So that makes it harder to provide computational access to users. So we kind of dealing it in different ways. And where I found some similarity with this OSP project, we have portal that allow users to do some analysis, like text mining analysis, and without getting the content. We also have a data API where people can send a request to our data API and then get public domain especially the non-Google digitized public domain content, and then they can at their local machine they can do analysis. And finally, there is a secure environment we are developing called Data Capsule Project, where people can freely use the data, but they cannot bring out the content out of a secure environment. So we are kind of handling things in different ways and at different flexibility, so that people, if they are less familiar with text mining skills, then they can go to the portal and get results from there. But they are not taking the content away, which is the key. And for more advanced users, they can get public domain, non-Google digitized public domain content, and then do the analysis themselves. And there is even more advanced option where people can run their own analysis on our virtual machine. And also it prevents people take away the content. I don't know if you are fine with me continuing or you want to.
Yeah, well,
okay.
You can keep going on and then to finish, yeah.
Okay. So, and after hearing this morning's session, I do find a lot of similarities between the issues here and the issues in HTRC. And so by the nature of this project, so we do have technical challenges in this aspect, and I have an explicit list. So we have the computational access for non-conjunctive research. We want people to do research with these materials, but we don't want them to have the content, so they can't write a program saying, I want all the strings of the text, and we can't allow people to do that. But they can get some features away from our collection, such as we recently released a feature, kind of a feature download thing, so that people can download some bag of words features like word frequency count and where is a header and where is a footer of a book, such features. But only with these features, you cannot reconstruct the content of the text. And since book content is kind of very unstructured, it's even more difficult to get structure out of the text compared with syllabus. And we also have the version control issues. We get content from HathiTrust from time to time. We have to synchronize our content with the home HathiTrust, so such that we make sure our content is public and the copyright is in negotiation now. So when we get content from HathiTrust, then how do we do the version control during different times? And the HathiTrust is a collection over time. It's a huge collection, but there is also other collections in external resources. And if we link up these resources with other things, then it's kind of powerful. And I can see many collections here by the people here, so it can be very powerful for that kind of analysis. So that's another issue to be considered, the challenges, because it's kind of heterogeneous resources. And regarding about machine learning, we do provide machine learning functionality in the portal, and it's a fixed algorithm. You can adjust several parameters, but maybe for advanced users, they want to run their own analysis. And some machine algorithm doesn't scale well on large scale, so that's the issue we have to consider. If just thousands of book volumes, then it's fine. But if the volume grows to the whole collection with 11 million, then it's an issue. So we also have the curse of dimensionality because a book contains millions of words, and this kind of issue should be considered in kind of large scale. We need to select a good platform infrastructure for this. Well, currently we already have a solid infrastructure for HathiTrust to build up services on, but we need a good machine learning suite for that. So we kind of in the process of allowing some people to do experiments on our virtual machine, and it has been a kind of discussion in our internal group how to do the provenance of these experiments, and if they want to replicate some experiments on a particular workset, kind of their own collection, then we have to keep this kind of provenance information. Finally, because our text is from OCR, which means there are always OCR errors in our text. So the books are scanned. Some books are scanned by Google, some are scanned by libraries. So when we get a digital content, it's already OCR content, and there are always errors there. And if we clean up the content, how do we do that? There is not a single solution to that because the books are from different times and in different languages, and so there is not a single solution, though, like British text or American text. And if we clean up, there are different rules to do that. If we clean up, there also comes up with a version control issue, like if someone do it in this way, how do we keep the this version? Like another version, how do we keep it? So that's all the technical challenges that we are facing, and it's glad to find this kind of similarities here and to discuss with people.
Yeah, that's great. And do you guys do any extraction? Like yourselves, metadata extraction, like, or does it? Do you usually get the book already with the title, author, or whatever?
Yeah, the book.
Yeah, I was just going to say, you know, the metadata that we've gotten over time. At first, you know, because it was part of the Google Books thing, they didn't think that was all that important. But then when they really started to hone in on, okay, we want an aggregate, everything that's in the University of Michigan library, but we're going to collect it from, you know, 30, 40 different libraries. It became really important because you wanted to make sure you had the right volume when, you know, you're really just trying not to replicate over and over, you know, the same volume. And so there's still some real issues there. It's basically based around a MARC record from a library type of holding, but then they came from so many different places that it's kind of all over the place. So that kind of feature piece needs some real work. And we got a Mellon grant that's underway now, and the whole piece was to put out challenge grants to research teams that wanted to enhance that kind of feature set, both from what we know about the metadata and both from mining the text. So we're hoping that we'll have 6 or 8 of those kind of things to show in the next year on what's really possible there.
That's a new technical challenge.
Yeah, that's right. That's right. And the technical challenge will be to integrate those into our production services, because once people realize what they can do there with that enhancement, they're going to be like, okay, put this into HathiTrust Research Center. Oh, we really like that in regular HathiTrust too. So when we're just doing a regular search across, you know, the volumes with Lucy Solar, that's going to come up.
Yeah, especially absorbing a couple of these different takes on versioning and you know, dynamic feature extraction in the cycle over here. I'm wondering a bit about you know, how important it is that a particular search or analysis come up the same way each time or over time. And so, you know, for example, I think we've gotten used to using tools like Google that, like, hey, you could get a different result tomorrow than today. But depending on some of the requirements and expectations on the research side, for example, like, I wonder if it would become important to version your collection at a particular point in time. Because if I understand the machine learning stuff at all, I think if you, like, you know, tomorrow came across an entire corpus of medical syllabi, you put that in and it would actually, like, alter, you know, like, the rest of the collection and the ways in which you do the analysis. So I don't know, like, how important it is to folks that this be regarded as, like, a rigorous research tool that could be used to replicate results over time, or the version of the collection when the tools were run, or if you guys are thinking about that as well. But it is, like, in the mix. That's a big question.
So the whole work set, Mellon grant that Robert mentioned, had this notion of work set. I'm not sure if there is a version control project on this, but yeah, we are also aware of that.
Like a version of the entire collection.
Right.
I mean,
And also,
like, and when you ran the tools against the collection.
Yeah, and also there is the issue of different individuals' work set. It also evolves over time, and there's also version control there.
Well, it's not. It's in no respect a representative data set, right? I mean, it's what we can find.
Right.
And it arguably gets more reliable as we get larger numbers, but it's not, you know, it's not a random sample by any means.
I just don't know if it's obvious that there's a holistic quality, you know, to the tool, to the analysis.
It's a very interesting question. Yeah,
right.
I hadn't thought about that.
I think it speaks to, like, someone's trying to replicate the same results that he got.
Yeah.
And you got them, you know, then
think this is one example of a data set that is continually being updated, but certainly there are many other data sets that out there in the realm of research that are facing the same problem and how they're dealing with it as far as applying DOIs to different versions of the data set, so that research questions and the results and the analysis can be replicated at a later date, just to demonstrate that, yes, this wasn't a quirk of the algorithm at that time, really this works in other ways too. So I think it's an important question for this particular data set.
Yeah. So we have thought about this a little bit at the level of institutions. So if we get access to Columbia's 60-some thousand syllabi, and we know that that's 50% of the syllabi that were offered over the last 10 years, we can begin to make those kinds of representativity-based claims. And lots of other kinds of tools become available once you have a representative or eventually verging on a complete data set for a particular institution or set of institutions.
I mean, I think this question is a very hot topic right now, not just in digital humanities, but in science and academic publishing in general, and that is reproducibility of results. All right, so we're used to just presenting some sort of like, we studied this and here's the paper. And nowadays there is a desire to replicate down to the data, but note that there's like, it's turtles all the way down. Why not, like we want to version control Mongo, but why not take snapshots of the whole server and just keep, so this way somebody can come in and replicate the whole environment, including the packages that we use. Like, what if, some kind of NLTK Python package got improved and now it's, right, so you want to kind of fix as much as possible, it's very interesting to think about it. And that's where I actually feel like we're privileged a little bit, because we can leapfrog in the humanities, in the English department, we can think of ways. I do think we are operating an infrastructure that actually answers to that standard of reproducibility. To, like, we do have snapshots. We do take daily, weekly, monthly snapshots of the whole server, including MongoDB. It's not version control per se, but it allows us to go back a year ago and just see exactly, right, what was there. We can imagine a researcher down the line who is maybe going through the digital detritus of our lives. They can go through and kind of reconstruct a project from the beginning. So I think that's a great question, and one that's probably relevant to all of our research in some way.
Okay.
With that, let's hear from Citeseer.
Okay, so my name is Jian Wu. Come from Penn State University. This is my boss, Dr. Li Zhao's. He wasn't able to come here, so I just do the presentation for him. As you know, that we are from Citeseer, and we're doing. So Citeseer is the digital library search engine, and many people may have been used that before. So I'm here to. So in this presentation, I'm trying to put the Open Syllabus project in the context of big data. The reason for that was because, as I was asked, there is 1.5 million syllabi already, and if we are incrementally collect more syllabi, eventually it can grow up very quickly. So we may want to use some way to process this syllabi in the environment of big data. So in this presentation, I will give you some brief review of the experiences we learned when we're doing Citeseer. Okay, so what is scholarly big data? Generally, all academic research documents include journal, conference books, theses, and technical reports. They are scholarly big data. And there are other scholarly big data, including the lab web page, funding agencies, grants, reports, and patents. Actually, we also have a patents here. There are associated data like slides, video, course materials, and syllabi is, of course, one of them. And there are some existing search engines that people can use. And some of them are well-known, like Google Scholar, Microsoft Academic, and some of them are publishers, and like NSF and some others. Okay, so these are things. These are big search engines that's hosting the Scholar, the big data, and inside this big data, what Citeseer focusing on is the scholarly documents. This document includes like millions of documents, and we have estimated. Okay, Microsoft Academic contains about 50 million records, and a recent analysis by our group, by Martin Kapsa and Dr. Giles, they estimated that there were 120 million academic documents on the web. And this results being published on PLOS One, which is the journal under Nature. So, and about 1/4 of them are free. So, so that's a lot of documents. So you really can't process them in the regular methods. So you need to put them in the big data environment. And we have like these records will have hundreds of millions of authors, affiliations, locations, and date, and billions of citation mentions, lots of figures and tables. And the raw data can take petabytes. Okay, so once we have the data, and here it comes with some issues of how to deal with the data. First is data management. How do we manage the data? How do we store them? How do we save them? Collection, and then databases. Large-scale experiment. Let's say if you want to do some experiments that you want to use millions of documents, how do you deal with that? So that's an issue. And search and access. You want the search to be quick, right? And this is AER is name entity recognition. That also happens in Syllabus, because let's say you see a name on the Syllabus, John Smith. Who is John Smith? Where is his who is him? Is this the John Smith in Stanford or John Smith in Cambridge or somebody else? So you need to disambiguate that, and that's important, right? And data integration. You want to put all data all together. Collaboration and sharing, visualization, privacy and security. That's not where, right? We don't care that a lot, because all our cloud documents, they are free accessible. I mean, they are so everybody who has internet, they can download that, and we provide the original link to this document. So here's the number. So here's the issue: like, how do we estimate the total number of documents? So that's the results we just published in the PLOS One, and as we estimated in early 2013, the total number of documents is around 120 million. That's a lot. And Google Scholar has about like 85% of them, and Microsoft Academic has a relatively lower fraction. Okay. Here's just a brief summary of the results we have got. And we have communicated with Microsoft Academic Search, and we have confirmed that we got confirmation from them that our estimate is roughly consistent with their collection. So besides this, there are other things that we need to do besides this the big data, like distinguish between publication types, paper, thesis, technical report, etc. We recently have projects to do binary classification of PDF documents, like whether it's academic or not. That's important because you want everything to be automated, right? That's one thing of dealing with big data. But also you can classify them as paper, thesis, the technical report. So like people can do the fastest search, because it's called fastest search. Like let's say if I search a title called machine learning and I just want books, okay, and then you can just choose books and then it will give the results of books. And if I just want papers, and it will return you the papers instead of the books. Okay, here comes Citeseer. Citeseer crawls researcher home pages on the web for scholarly papers, formerly in computer science, and now we are keep adding more disciplines and domains, such as medical science. We have 500,000 papers ingested from PubMed, and we also we're crawling. We're actually keep crawling this economy, the website of Economist, and we're keep adding papers from physics, something like that. And now we have 4 million documents searchable and downloadable from Citeseer, and millions of files. We have about 10 million of citation, 4 to 5 million authors, 2 to 4 million hits per day. That's huge. So this can be viewed from our web server log. So you can get that. And also we have set up an account on Google Google Analytics, and we can see that we really have a lot of hits per day, like a million hits per day. And we have about 100,000 documents added monthly, and about 300,000 documents downloaded monthly, because not all of them are academic. So some of them are not. Like some of them are resumes, and we don't keep them, right? Okay. So this is the interface of Citeseer. So we go to citeseerx.st.psu.edu. So this is what you will see, Citeseerx. And there's a search box out there, and you can search the title of the paper you're interested in, and then you get the result. Yeah. So besides the document, we also provide a tool set called Seer Suite. And Seer Suite is open source scholarly search engine and digital library toolkit used to build academic search engines and digital libraries. So there are several places that were pretty interested in this tool, and they have been using this tool to build their own digital library search engine. It supports and our data supports research in indexing and search, data mining structures, information knowledge extraction, social networks, and all kinds of this. And we also train students in big data search and software systems, because in some college they used to use the Seer Suite as educational tools in their classes. Okay, so here comes up the research topics about information extraction. The information extraction is being used in lots of areas of research: data mining, semantic web, information retrieval and search, machine learning, and text recognition and understanding. And there are several open source tools available, which is listed here. But there are still some major research issues about the information extraction. One of them is semantic extraction. It's like we are, like for example, like given a paper of the search fund, how does machine understand what this paper is talking about? Is it talking about search engine, or is it talking about food allergy or something like that? That's a really big challenge. And another two are performance and extraction at scale. That means accuracy and speed. So we want the information extraction to be fast, so we can process millions of documents in a reasonably time scale, and we want to be accurate. So how do we get metadata? So we can't do things like this, right? Just like manually paint the house, paint the trees, paint the dog, paint the cat, something like that. We need something automated. So this is our basic pipeline. So we're interested in the PDF files. So most of our files are PDF, and some of them are PostScript, but they only takes a small fraction. We first extract the text from these PDF files, and then from the text we can do the information extraction. So basically we extract the header, which includes the title, the authors, the abstract, the year, the venue, and all sorts of information. And we also extract the citations. Like one paper has references, we got the citations
And from the citation, like each citation contains a title and the venue and the year and some of other information. And we are also extracting tables, because tables is a very good way of representing the experimental result, and figures, and formula, that's we call algorithms, and all sorts of things. And here we also do something called near duplicate detection, because authors tend to put like different versions of their papers on their website. Like if let's say the deadline is a month after, I may put a version today, but later on, like a week after, I may update my version. So when we do a new version, we will crawl them, and we keep both of the versions, and we allow users to choose like which one you want to read. And so here comes an important topic called name disambiguation. It's very interesting. Let's say, so there are basically like actually three cases. One case that you have one person with multiple aliases, C.L. Giles and Lee Giles, Superman, Clark Kent. So they actually refer to the same person, but you need some more information to know they are the same person, right? Another is common names. For example, if you search Jian Huang in Google Scholar or Microsoft Academic, you will get over 300 papers or more than that. Does it mean that this person has that many papers? No, because this refers to many people, right? So you need to tell them to distinguish them. And there are also some typos, like people just type their names wrongly. Okay, and here comes with the table information extraction and search. I think this also applies to syllabi, because many instruct they include tables in their syllabi. So you may want to. The current search engines treat the table data as regular text, but they just neglect the structural information and the semantics information. And where there was table competition last year in ICDAR, and in this competition, they will like provide some PDF documents which ask people to like extract them. They got some pretty good results. And figure extraction is also important. It's under development, and we are working on that. And you will soon see that on Citeseer, because from figures you can really learn some quick results. Okay, just some brief summary. Scholarly big data contains petabytes of data, billions of objects, rich content. We can apply them to science, research, education, patents, policy, and all sorts of things. And these things, and this is growing very, very quickly, right? So the issues involved in this big data are like information extraction. So that's still a very important topic that we need to address. It's constantly improving. Like people are using like more material, so more mature machine learning method. And now our group member Alex is developing a deep learning method to extract the information more accurately. So and you can use like neural networks and something similar. And data is not always easy to move around and share. I just talking about our data repository, which contains 6 terabytes. So it's not easy to move around and share, and even it's not easy to duplicate, to back up. Some data are still readily available, but changing. But like I said, only about a quarter of all these documents are freely available, and scaling is always an issue. Okay, so this is the last slide, which talking about the lessons we learned from Citeseer. The data management is painful. Yeah. The cloud computing the cloud computing is a very hot topic now. There are many conferences on this and many publications. It's somewhat helpful because it's use and go. Like you can scale this server. Like say if you want 250 gigabytes of data, okay, now you have it. And if as data grows, you can increase it to the quota to 500. That's okay. But there's still a limit there. So you need to think other ways to deal with this problem. So cloud is not a complete solution. And also the scholarly related data is growing very quickly. As you said, and for the syllabi, we may have, well, let's say, tens of thousands per year, maybe, or more. So it's growing very, very quickly. And the big scholar data create new research because we have new data. And the big scholar data creates other big data because you can get metadata from them, and you can get more science from them. You can dig this. You can do this big data mining from the big data, and that will create new big data. So there are lots of challenges. So these are the things that we can we learn from Citeseer, and I hope that they could be useful for the Open Syllabi project. Yeah.
Right. Thank you very much. Any questions from the audience about this talk, Citeseer, HathiTrust, or any of these projects? Yes, please.
Yes.
Alex.
So you mentioned that you occasionally get non-article documents, such as resumes, coming in.
Yes.
Are those being separated out algorithmically, or is that being done by hand?
No, you can't do it by hand. Yeah, you have to do it automatically. We have a filter on that, which which is a rule-based filter. It works pretty well. Actually, it has precision about 85, 90%. So it can filter out most of the non-academic stuff. Yeah.
And these are the parts we've been talking to members of your team and to Lee Giles about reusing some of that engineering, because we're also we have some junk that we need to filter out, and
yes.
there's no reason to duplicate this.
Right, especially if your data comes from web crawling. So you need,
which it does.
Yeah, you need to build a filter to filter out the things that you don't want. Yeah.
Yeah, I think exciting, one thing that we have not addressed directly, but something that's exciting for me, and I think it's important, is that, so your two projects, HathiTrust and Citeseer, right? Citeseer is kind of a response to Google Scholar, in a way, right? Not a response, but it's a parallel project, and it attempts to make sure that this collection and extraction remains kind of in the public hands, right?
Right.
The same thing with HathiTrust, right? Kind of a response to Google Books, right? We want to make sure, and I know it's been a little bit less of a discussion in this country, but in places like Europe and other places, the fact that one company may have a monopoly on all of scholarly publications is worrisome. It's not, it hasn't been so, nothing bad happened yet, right? But we don't know. And I think this is very much in the spirit of Open Syllabus project, and it's neat here that we're not being reactive. We're proactively gathering this data before kind of Google or Microsoft gets there first. So that's exciting, and I think that's a really commonality between our research and our projects that I see.
Right. So somebody may say that, okay, where do I have Google Scholar and where do I have Citeseer? The answer is that Citeseer has this unique position because it has some data that Google Scholar does not provide. For example, the citation context. So that means that, let's say you cite a paper and then you want to know, okay, and you want to know in this paper where this reference is cited and what the context around that. So that may tell you more information, like why this paper is cited. Okay. Another big thing is that our software, the Seer Suite, is publicly available. So it can be used for educational purposes, or Google Scholar will provide that. Right.
And then on top of that, you have the knowledge of the inner workings of Citeseer if you ever need it.
Right.
That's the benefit of research. That's kind of like, this is
Right,
But
right.
it needs to protect its proprietary information, but a lot of scientific cutting-edge advances don't get released to the community to propagate. So it's a nice thing at Citeseer, like you said, a parallel project. So
Right.
Syllabus is that the insights that you gain in there are also trickling into the academic circles as well to say, hey, look, here's a novel algorithm that we've used to solve our problem. We don't need a competitive advantage. Here you go. And then you give it back to the community, which I think is better than these big open source architectures.
Yeah. Right, and that's something that you mentioned in your slides briefly, is that there are these spillover effects. So the fact that this can be used in instruction to teach students how to create their own search engines. I think that's very important. It's very important for us to make sure that students in the humanities, students in the English departments, in the history departments, get some of the same skills to tackle questions on an entirely different level of analysis, right? This kind of data approach to questions that span a long time, that span millions of documents, we would really like to make sure that some of that expertise is captured in our department as well. And you have over there in the back quietly sitting graduate students who do this as a matter of their daily research practice, which is kind of, to me, that's an exciting kind of and very, very important byproduct of what we do. And that's what does not happen in some of the more closed systems. So with that, I would say, if there is no more questions, how are we on schedule, Joe? I think we're
15 minutes behind, but
okay. So maybe yes, another question. Last question, perhaps.
Here,
Okay.
This might add more complexity to it, but they're academia.edu and ResearchGate, where it's like a social network for researchers, and I'm on it, and they allow you to upload your preprints for papers.
Yes.
Are you scraping that as well? Are you like following through?
Well, it depends on the copyright, and also it depends on, there's something called robust.txt. I'm not sure you heard of that or not. So robust.txt. Okay. Well, let's say. Okay. Let me give you an example. For example, if you go to archive, do you know archive? Okay. So if you do archive/robust.txt, okay, they have some rules here, and it tells you what things you can crawl and what things you can't crawl. So if they specifically specify, okay, this directory you can crawl, we honor this. This is not a law, but it's pretty much widely accepted agreement. Right, so we must follow this agreement. If it does not allow us to crawl, we won't do that. We honor this.
Yeah. Citeseer, in a way that it also follows the general understanding of the web, which is it's an opt-out system, not necessarily. So when you put your information on there, it's essentially available to everyone, unless you specify, or unless you pull it down. And so the thing that's a little bit different than the open syllabus, at least we talked about it, is that we deal with those requests. So like, for example, if the robots, they don't have a robots.txt, or if they don't specify, or we find a way that we can get the data, and we're not like going out there knocking on everyone's doors, but if we pull that information, we're going to use it, and then it's up to you to contact us, and then we deal with, okay, you want this taken down? Sure, and we'll do it. But that also gives burden in terms of maintenance as well. And some, like for example, the open source project may not want to deal with all those requests, because you can get like, hey, I don't want to deal, and that's where we get back into the legal issues that we were talking earlier. But we do deal with the idea of the opt-out principle.
And then once someone's made a request, do they go into like a blacklist or a white list, or so that you don't call them straight again, or?
We have blacklist.
Blacklist.
Yes.
Okay.
Yeah. So there's, they mostly depends on publishers.
Yes.
Yeah.
Not, they're saying, I want to be on the blacklist. Don't screen me.
Yeah. So we have a blacklist which contains about 500 domains. For example, IEEE.org, ACM.org, and Springer.com. They don't allow us to crawl. They just tell us, we just put them, So once we see the URLs from this domain, we just skip. Yeah.
And we also found whitelist storage too.
Oh, yeah. The whitelist is the whitelist contains like hundreds of thousands of URLs that contains academic files that we used to crawl. So these are URLs we crawled before, and we found academic documents there, and we believe that it's more likely they will update their website to post more academic documents. So it's worth to recrawl them. So that's the whitelist.
And they get priority over just
it depends.
other things.
Yeah. So there are two things that determines the priority. One is the number of documents we retrieve from this URL. The more documents we retrieve them, the higher priority it is. Another thing is that like how often it's updated. Like if it's updated frequently, we put them at the top. Yeah.